All right, so let me go ahead and clear. Let's move on now to our beautiful topic of today. Today, we're gonna go ahead and identify corresponding parts of congruent figures, okay? So, in essence, this is what it states. I'm gonna go ahead and have a figure, right? Imagine that this is my figure. I'm gonna go ahead and rotate it. I'm gonna go ahead and reflect it. I'm gonna go ahead and translate it, make it do whatever it needs to do. But whenever I create that transformation, my first figure and the second figure are going to be congruent to each other, right? Their parts are going to be congruent, their angles are going to be congruent. Therefore, we can go ahead and state that my two beautiful figures are congruent to each other. Our job is to identify the parts that are congruent to each other, right? After they've been transformed somehow. We're not going to mainly focus on transformations like how we did yesterday or how we've been previously doing. We're going to go ahead and focus more on the parts that are congruent to each other. Okay. Now, I want to ask you guys a question. You guys ready? Yes? No? Maybe so? Be honest with me, okay? How do you guys make a peanut butter and jelly sandwich? How do you guys make a peanut butter and jelly sandwich? All right, Brendan.
Put the peanuts on. Put the butter on. The other one is they squish them together.
And then you mix it. Now, does anybody have like a special way to make it? Like it has to be like a specific way, otherwise you guys don't like it. Or it's just like no, you guys don't like the mix. But it's just so easy for you just to grab it when the pass returns. Well, I like to make it, guys. Well, what do we need in to make a peanut butter and jelly sandwich? Bread? What kind of bread? Wonder bread? Bimbo bread? There's peanut bread? Just white bread. Okay. So I'm pretty sure you guys will need some kind of items here. So I have some pictures here with the items. This is the way that I like to make it. Well, actually my husband makes it for me because I'm spoiled and I like for him to make my sandwiches because I like to be spoiled. Okay. All right. So I need peanut butter, I need jelly, I need bread. It can be any kind of bread. Particularly lately, we've been eating potato bread. Have you guys ever tried potato bread? It's like very soft and it's the texture of it is very different. And then we also like putting bananas in it. I usually didn't like it before, but now that I've been trying, I'm like, okay, I can live with this. I can try it out. So we put bananas. Huh? Ice cream with your peanut butter and jelly sandwich? Really? Just regular vanilla ice cream? Okay, I'm gonna try it now. Yeah, that's what Viviana was talking about. She was like, did not get that. Yeah, they sell them already. They're already pre-mixed, basically. The pre-mixed are already mixed all in one, 2 in 1. The Uncrustables. Those are 2, but I don't like how whenever they do frost, they get a little soggy. I can't handle that texture.
Also, like it's like dry. The outer is dry. Yeah.
Yes. What if you toast them?
Oh.
Oh.
This is personal experience. Do not microwave.
No? What happens to them if you microwave?
They seem to explode and get yeah.
Oh no. Toast them. Yeah. Okay. So this is the way that I make them. I like bread. I like peanut butter, jelly. It could be either grape or strawberry. Yeah, grape or strawberry. Whichever one we have. I don't know. We always buy one and then I don't pick one. I don't care. And then we have our banana. Now, So my husband likes to make the sandwiches where he grabs the skillet and then, or the comal, and he puts a little bit of butter and then he just like warms them up and he just toasts both sides and it's just nice and warm and just really good. Okay. So, like I said, I'm very spoiled. So it ends up looking like this. So we make it and then, we have our triangles. I like to have it cut diagonally, just because my grandma used to make my sandwiches, just cut it into like a triangle when I used to eat them. I used to like eating the center part first here. That little bite, guys, is not mine. My son decided to take a bite while I was not looking. So I turned around and he was like, Mom, I ate a piece of it. And I was like, oh, okay. But back in relation to math, how does this relate to what we're going to do today? We're going to go ahead and look at the figures. We're going to go ahead and look at what we've created here. And because we've cut the sandwich in a diagonal portion, or we could have cut it also vertically or horizontally, we should be able to identify my triangles here that I've created with my two parts now. Now, today, we're going to go ahead and focus on the corresponding parts that are congruent to each other. Okay. Now, where do these beautiful parts exist? They exist anywhere, basically. In essence, whenever we have one item or one figure and it needs to be replicated many, many times, that is when, again, the corresponding parts we can go ahead and identify that are congruent to each other. Okay. It can be found in building structures, in arts, in playgrounds, in jewelry, in anything that you guys can think of. Even right here on the structure, you see our lights. Let's see what else. Anything. The stripes on the flag. My doors on the cabinets over there. Basically, anything has a corresponding part once it's been replicated many, many times. Yes. The pencil. The posters, yes. Anything that you can think of, it has basically, if it has a copy of it, it's going to be considered to be congruent to each other. We have to correspond the parts to it. Now, the parts that we're going to focus on are two. The figure sides and the figure's angles. So those two items is what we're going to go ahead and just focus on, or just concentrate on, so that we can go ahead and state that the two items are, Adon is first. After Adon. So that we can go ahead and state that we have congruent figures. Now, here's our definition. So go ahead and copy this one down, guys. Corresponding parts of figures are congruent. It states if two figures are congruent, then their corresponding sides, like I said, we're going to focus on the sides, and we're going to focus on the angles are congruent. So we just need to prove that those two items are true, that the sides are congruent, the angles are congruent, so we can go ahead and have corresponding parts of figures that are congruent, okay? So we're going to be given some statements. We're going to follow along with the statements, and then we're going to identify the corresponding parts. All right, everybody has this, right? Perfect. So we're going to go now back to our beautiful figures. Now this time we're going to see our beautiful pieces of peanut butter jelly sandwich that are cut into two congruent parts. Be labeled with our points A, B, and C on one side, and D, E, F on the other side, okay? Now, we're going to go ahead and state that triangle ABC that we've created now with one length or one side, be congruent to your other triangle, DEF. Now, we're going to go ahead and create 6 congruent statements about our segments and angles, and basically why they're congruent to each other. So, 2 items that we're going to be focusing on, sides and angles. Now, in this particular example, we have triangles. How many sides do triangles have? 3. So therefore, we're going to have 3 statements of congruency with our lengths. And how many angles do we have in a triangle? How many angles does it have? 3. It has 3 vertices, therefore 3 angles. A, B, and C. Over here it has D, E, and F. So it has three angles, three inside angles. So we're gonna have another three statements of congruency. So let's go ahead and create our statements. Let me see. I'm gonna do sides and triangles. So let me go ahead and highlight my first one. Let me see. Let me focus on AB. So AB is right here. Now, if we were to look at AB and see that something happened to this figure in order for it to become the other figure, so it was transformed somehow. I think like would it be a rotation since it has to be just this way, the orientation of it? What length or a side is corresponding to AB on the other triangle? It would be ED, or in this case, DE. I'm going to go ahead and write it in alphabetical order. So since those two are corresponding to each other, we're going to go ahead and state that they are congruent to each other because we have our congruent statement. So I'm going to go ahead and focus on my sides. Let me see. Let me write this sides. So let me start with AB is corresponding to DE. And therefore, since they're congruent to each other, I'm going to go ahead and state that AB is congruent to each other. And DE are congruent. Now, let's go ahead and do the next one. Which are my next lengths? Let's do, let's see. Let's do BC. BC is corresponding to, it would be not DF. Notice that this is shorter. It would be EF. So those two lengths are corresponding to each other. So let me go ahead and write that down. So BC is corresponding to EF. And since those two lengths are congruent to each other, or those two triangles are congruent to each other, I can go ahead and state that the lengths are congruent to each other. So BC is congruent to EF. All right, and the last pair of sides. Let me do this one in pink so you guys can see it. So let's go ahead and do now AC. AC is corresponding to DF. So in this case, let me go ahead and write that down. AC is corresponding to DF. Therefore, AC is going to be congruent to DF. All right. So here are my 6 congruent statements. Let me go ahead and highlight them so you guys can see them. AB is congruent to DE. BC is congruent to EF. And AC is congruent to DF. Not too bad. All right. Let's go ahead and do the same now, but for our beautiful angles. So let me write angles now. A ver, so let's go ahead and start with angle A. Angle A is corresponding to what angle on my triangle DEF? It would be D. So let's go ahead and state that angle A is corresponding to angle D. So therefore, measurement of angle A is congruent to the measurement of angle D. All right, let's do the next one. Let's start with now with B. B is corresponding to E. So angle B is corresponding to angle D. Therefore, the measurement of angle B is congruent to the measurement of angle D. And the last one, by default, we have our beautiful angle C. Is corresponding to F. So angle C is corresponding to angle F. Therefore, the measurement of angle C is congruent to the measurement of angle F. So we were able to identify all of our parts that are corresponding to each other. And we were able to identify now the parts that are congruent to each other by the statement of congruency that we have up here. So we're stating if this is true, then we can go ahead and state all of these statements as true. Not too bad, huh? Not too bad. Ready to put this into play? Ay, Dios mío, I love your guys' enthusiasm. Ready. All right. Is it too much? You guys got this. Did everybody have that? Okay, let me go ahead and clear. Did you have it? Nice. Yes. Go back. There you go. I saved an image and I can go back to this. Okay. All right, let me clear. Let's go on to our next example. Okay, so just very quickly, guys, do not confuse this with similarities. Similarities, when you apply a dilation or a scale, we'll see that in the future lesson. Today, we're just going to keep the triangles or basically our figures congruent to each other. So you'll just see the same shape. It'll just be transformed somehow. So the application of the transformation will be applied. We don't need to state this transformation. We just want to know which side is corresponding to what. That's what we're gonna focus on today. Okay. All right. So first example 1A. Go ahead and copy your beautiful quadrilaterals JKLM and PQRS. We're given the statement that JKLM is congruent to quadrilateral PQRS. We're going to go ahead and find the corresponding side or angle that is given here. We have to find the corresponding side and the measurement for JM, the corresponding angle and measurement for angle R. Okay. All right. So I'll let you guys copy this one down. All right. So now let's go ahead and identify the corresponding parts. We have a length JM. Let me go ahead and highlight it so you guys can see it. JM is right here. Now, by looking at the other figure that we have over here, we notice that there was a rotation, or it can be a reflection in a translation, or a series of reflections that happen, one this way and then the other way, and then translation. A series of transformations have happened, right? Where now our beautiful sides are there, but we need to identify which one's corresponding to what. So we have JM. Which one's corresponding to JM of my other quadrilateral? PQRS. Right. It would be SP. So it can be SP or in this case PS. Now, what I'm going to look at now is that I have these two lengths. Since they're corresponding to each other, they are also what? They're also what? They're also congruent to each other. So I'm going to go ahead and write that JM is going to be congruent to PS. Now, they're not given measurements, but we can go ahead and just identify the corresponding or the congruent figure. Now, let's go ahead and do the same for angle R. Angle R is where? Down here. And angle R is corresponding to what angle? Go ahead and tell your neighbor, what angle is it corresponding to? Your neighbor should know. All right, raise your hand if you think it's K. Raise your hand if you think it's L. I have 1, 2, 3. They're raising their hand. 4, 5, 6. For L. L. Okay, so I have half and half the class. So let me see. There are several ways to identify, and I'll go ahead and show you guys a trick right now, okay? Now, here's angle R, right? My side that is made by R is the short side and the slanted side. So I'm going to look for the short side and the slanted side. Short side and slanted side. So it should be corresponding to L in this case. Now here's my straight side, So let me go ahead and write that this one is corresponding to angle L. So therefore the measurement of angle R is congruent to the measurement of angle L. All right. Now Another way to identify is by its congruence title. What is the congruence title, Ms. Vasquez? Well, the statement that's given whenever you have your figures. You're being told that one figure is congruent to the other. Now, whenever we write the congruence title or it's written in a form where the corresponding part has to be written in a particular order. So, in this case, J has to be corresponding to P. K is corresponding to Q. L is corresponding to R. And M is corresponding to S. So if we were to focus on angle R is my third point or my third vertex. Therefore, it's my third point or vertex in my other statement. So in this case, I have JKL is my corresponding part to R. Okay. So not too bad, right? So there's two ways, either by looking at the figure or by looking at the statement. So the statement tells me which one I have here as corresponding. And you can do the same thing for lengths. Notice here my lengths, I have JM, right? So JM is my first point and my last point. So therefore, the first point and the last point will be also true for your segments, okay? All right, ready for another one? Let me get it clear. Go ahead and try this one on your own. Try LM and angle S. Let's see if you guys can find the corresponding sides and angle. I'll give you guys like 2 seconds. I'm just playing. LM and angle S. They're the same figure, guys, so you don't have to recopy them. It's the same figure. It's the same figure. You don't have to copy this one. Okay, ready?
No, I just realized that it wasn't the same figure.
No, it's the same figure. I kept the same figure so you guys don't have to copy it again. Okay. ¿Listos? How about now? There's no talking. It's just identifying. Started just with this part.
Oh, no.
No. The homework is going to be very similar, but we're going to see now length and angle measurements. Now, my statement says that I have quadrilateral JKLM and quadrilateral PQRS. I have to find the corresponding side or angle that is congruent to the ones that are given. So LM is corresponding to, where's LM? Right there. From L to M. So which one is the corresponding side to LM? RS in this case. So corresponding RS. Therefore, LM is congruent to RS. And corresponding angle to S. It would be in this case M. So measurement of angle M or angle M is congruent now to S. So therefore, measurement of angle S is congruent to the measurement of angle M. Raise your hand if you got that. Ooh, let's go. Okay, now I think we're ready now. We can go ahead and put some measurements into this. So we can go ahead and identify our beautiful measures. Now, example number 2, guys, I'm just going to go and discuss this one really quickly. Triangles shown in the figure are congruent. Can you conclude that JK is congruent to QR? So what do you guys think? JK is right here. QR is right here. So what do you guys think? Are they congruent? The lengths. Could they or could they not? Here are the lengths that we're looking at. We're looking at JK right here and QR. Does it look like it's congruent? It looks, do we have enough information? No, why not? One looks smaller, one looks larger. Now, if we were to be given the congruency statement where they tell me that congruent or triangle, in this case, JKLM or JKL, is congruent to triangle PQR. QRP, goodness gracious, I'm stating them incorrectly. Then we would be able to state that they are in fact congruent. But since we don't have that information, we can't just say that they're congruent, even though they look very similar or very close in length. Andres, question. Similar means that they similarity means that they have a scale. So basically, you know, when you have pictures, right? And you enlarge the picture, that's a scale. So basically the same figure that you just expand. So I don't want you guys to confuse that scaling with today. Today, we're having exactly just a copy and paste figure. We're seeing just basically the same figure. It's just been transformed somehow. It's just shifted, translated, rotated, and reflected. So here's example number 2, guys, and this is our last example for today. Triangle STU is congruent to triangle VWX. So we're given the statement of congruence. Here it is. It says to find the missing sides or lengths or angles. Side lengths or angles. We're given the measurement, or we're given SU, measurement of angle S, measurement of angle U, and we're given our beautiful triangles STU and VWX. Go ahead and copy this one down. So for this one, we're going to go ahead and focus on the first length. The first length that we're given is SU. SU is what? This one right here. Now, by looking at my other figure, it's very obvious which side is corresponding to that. So which one is it corresponding to? Yeah. It would be VX in this case. So let's go ahead and write that it's corresponding to VX. So therefore, what is the measurement or the length of VX? 43 feet. So if VX equals 43 feet, we can state that VX is congruent to SU. Therefore, SU measures 43 feet. Not too bad, huh? We're just going through our statements here. So SU is corresponding to VX. VX is 43 feet. VX is congruent to SU. Therefore, SU is going to be equal to 43 feet. All right, let's do the next one. Let me do this one in. Let me do this one in blue. So now we're looking for angle S. Angle S is right here. This angle is corresponding to? V. It would be V. And now you can double check by looking at your statement. S is your first point here, your first point. So therefore it's corresponding to beautiful V. So V is corresponding to S. So therefore the measurement of angle S is 38 degrees. And the last one, angle U. Let me do this one in green. Angle U is corresponding to X. So therefore it equals 18 degrees. Not too bad, huh? No. All right. So I want you guys to get used to identifying the corresponding parts. Your beautiful homework is part of your workbook. So you guys should have all access to it, okay? If you guys don't have a workbook, then check in with me. I have extra in the back.